A few weeks ago, I have introduced the latest and most powerful AI chatbot, ChatGPT, and a few of automatic code generation tools. Today, I'm going to introduce how I can fast build some ChatGPT question and answering bot out of the scratch. So let's start. Okay. So how to customize the ChatGPT or GTP in general on your own data and use case? So this is multiple options. You can either fine-tune a GTP model like the DaVinci model or explore the proper engineering technique. So the concept for the fine-tuning is that this is some machine learning technique that involves further training a pre-trained model on your specific data to change and adjust its high parameters like the deep neural networks with. Actually, in this way, you can just optimize your model's performance on some new and specific tasks. So this technique, actually requires more deep learning training iterations and need more time and cost, okay, to do it. Another technique is the prompt engineering. So this is some natural language processing technique that involves designing and optimizing the prompts that is input for language models to generate the desired outputs. So this process actually involves careful selection and combination of the words, phrases, context, and formatting to influence the language model, the output in a specific way. So this technique actually don't change the deep neural network models parameters like the width and the bias, and it is faster and a bit more economic to do compared with the fine-tuning. Okay. So regarding the fine-tuning technique, there are three options at least. So you can either directly access the OpenAI standalone, the cloud platform to fine-tuning your own model. So this one, this is the OpenAI's fine-tuning the document for all the details on the instructions how to do it. Okay, so and then you can also using the Microsoft Azure Cloud OpenAI service platform. So this is suitable for some like the POC implementation for some big enterprise. So this is this one, the Azure OpenAI service. Okay, so which is with some security, privacy, and ethical AI, the hardenings and considerations already in place. Also, you can consider an open source alternative such like the Hugging Face Transformer library. Okay, this is also an interesting option. So this is available in Hugging Face portal, and you can always download and install the Transformer library to do the different data science experiments. So actually, I keep this as some option just like to compare with the other options, to see the what's their the implications in terms of like a total cost of ownership, the model performance, the ethics, privacy, security concerns, GDPR compliance, and so on. Okay. Also, regarding the GDP availability, the ChatGPT API is not yet available, but it will coming soon. And currently, some OpenAI GTP 3 and 3.5 APIs are already available. So I can show you that is some. This is some like the model index pages. For example, the code DaVinci 220 is the best model, good for pure code or completion tasks, and the text DaVinci 03 is an improved version on the text DaVinci 2, for the text generation. Okay. So you can also to look at the transformer library. So what a pity currently is only the GTP2 the available in the Hugging Face library. So this is this one. So Hugging Face GTP2. Okay. So And this all like the possible the GTP models and APIs we can try to use. So once you actually fine tuning using the like either Microsoft Azure or OpenAI's cloud platform to fine tune your model, then later on you can using the fine tuned model from the command line from the OpenAI playground. And also if you're using the open source library like the Hugging Face, you can train and deploy it on some premise and have the full control of this model. So that is the benefit. So you might ask how much will it cost to fine-tuning some GTP? So it depends on several factors, such like the size of your training data, the larger or your own training dataset, and the more tokens, the more expensive. And so it depends on the type of the GTP model to fine-tune. For example, DaVinci model is more expensive than the Curie and the Babbage ones to actually to tune. Also, it depends on the number of the training iterations. So the more deep learning iterations to run, the more expensive. So according to my rough estimation, so for some typical, the use case experiment to building your own fine-tuned models, it will cost roughly $300 to $400. So yeah, that is affordable. Yeah. Okay. So let's do some hands-on lab. So this is some fast prototyping GTP3 QnA bot using the prompt engineering technique. Okay, so let's go to the notebook. Okay, so question answering using the embeddings and the prompt engineering. So we know like you can always using the out-of-box GTP3 to actually to provide the answers to your questions, but often the GTP3 out-of-box replies is actually too general or not so accurate. So you always want to actually to try to customize GTP3 on your specific data and the use case. So that is totally feasible, and we need to actually to prepare some dataset and a notebook for such an experiment. Okay, so here I'm going to using some excellent the OpenAI's the notebook from their GitHub repo called the openai-cookbook. This one, okay. So you can see this one has got like a 13.9 thousand stars. It's very popular, and in the examples you will find some question answering with the embedding notebook here, and our experiment will based on this notebook as well. So and then we are going to actually using some Kaggle public available FAQ dataset for the chatbot training, and we are going to download the training data, and for our the fast prototyping purpose. So actually, specifically, we are going to using so-called the Seven Hills Hospital FAQ dataset for chatbot training. Okay, so is this dataset. Once you download it, you will find the all the text file containing all the test samples. Okay. Okay, so let's start. So first of all, you always like to specify the GTP models to use. This is text DaVinci 03. We see it before in this OpenAI's the model index pages. Okay, so this is actually the quite new GTP 3.5 model. Okay, to use. Okay, so then the first thing you need to do is actually to authenticate using the OpenAI's API key. So you have to refer to this actually to request and obtain generate your own API key. So here I just like to actually make some placeholder and hide my own API key for security and privacy, and always fill it up with your own API key here. Okay. So once you're done, you can also print out the model list of the OpenAI. And we know by default GTP3 is not expert answering these 7 Hills hospitals customer support questions. So let's actually to give it a test. So this is like the generated response, the script. So I just give some like a sample question. My report are in regional language. What do I do with 7 Hills hospitals in India? So you can see if a report are in regional language, you can contact 7 Hills hospital in India and ask if they have any staff members which can read, understand the language and blah blah. Okay. So the response generated by the Autobox GTP3 is either too general or the too the verbose or like incomplete or incorrect. Okay, so obviously the GTP3 needs some help here. So the first issue we are going to tackle is actually the sometimes model is just making up the answers. So it's actually just like some false and the fake, the replies. It's not so truthful. Okay, so and we had to agree to to make sure it's actually for air safety to prevent any like the false response from the AI model. So we can do it with the prompt engineering. So here you say, so answer the questions as truthful as possible, and if you are unsure of the answer, just say like the sorry, I don't know. Okay, so then once you agree to actually do this kind of the little bit addition of the prompt engineering, so the model reply sorry, I don't know. Okay, instead I'll give some like the some like the makeup answers. Okay, that sounds good. So in the next step, in order to help the model to better answer our specific like this kind of 7 Hills hospital question, actually we will provide some actual contextual information in the prompt here. Okay, and then when the total required context is short, we can include in the prompt directly. Okay, that is the case. For example, we can using this information taken from the hospital FAQ dataset. Then we update the initial prompt to tell the model to explicitly make use of the provide text. Okay, so it's here. This is our added the context to the original prompt. Then this is actually the the actual question. So you can see after we add this context, the model able to reply it correctly. You should contact your family doctor to get a summary of your record in English. If it's not possible, you can provide Sam Hill Hospital with the contact details of the person responsible for your cashless benefit and so on. Okay, that is sounds good. So and however here we just like have to manually add the context to the prompt. So can we automate this procedure? Certainly we can. So in the remaining part of the notebook, we are going to demonstrate a method to actually to augment the GTP3 with a large body of additional contextual information by using the so-called document embedding and retrieval technique. Okay, so this technique break into the 2 steps. The firstly, it retrieves the information relevant to the query, and then in the second step, it writes an answer, the tailored to the question based on the retrieved information. So the first step calls the openai's embedding API, and the second step, uses the openai's completion API. Okay. So in the terms of execution, the running and execution, this kind of the notebook. So this is like the detailed steps. So first of all, you have to calculate the document embedding vectors. So this is just like me, you have to pre-process the contextual information by splitting it into the chunks and create some embedding vector for each chunk. And in second step, calculate the document similarity. So you basically, upon the reception of any query from the users, so we can embed the query into the same vector space as the context chunks and find the context embedding vectors which are most similar to the query. So after we done the step 1 or 2, then we can prepend the most relevant context info to the original query prompt to augment it. So finally, we can submit the question along with the most relevant context info to the GTP, and then we can receive an answer which makes sense of the provided contextual information. Okay, so that is nice and clean steps to do. So let's try to execute it step by step. Okay, so in the step 1 asset, we need to actually to calculate the document embedding vectors and to pre-process the document library. Okay, so in this step, actually the sections to be used as like context should be large enough to contain enough information to answer a specific question, but also should be small enough to fit one or several into the GTP3's prompt. So OpenAI researchers is found actually approximately a paragraph of the text is actually the good good length to use. Of course, you can always experiment for a particular use case. So for our own specific dataset here, we said we are going to using the Seven Hills Hospitals FAQ dataset. So basically, I just like first of all to ingest this dataset into the pandas data frame. So you can see this is a question column, this is answer column, because the each like the answer is actually just like the a paragraph of the text. So naturally, this is already being can be act as like a right candidate as like the sections for context. So yeah, so this is also I also set the question column as the raw record index here. So because once we build in the document embeddings, we need some like index column actually to retrieve each like relevant context embeddings. Okay, so next step, I just detect and remove any duplicated records. So you can see before and after like the dropping the duplicate records, that frame dimension is still like 33. So that is no duplicated records. That is good. Also, you can see here this sample dataset is only have like 33 samples, not too much. But actually, for our just like for fast prototyping, some like a QnA bot is already enough for the demo purpose. And in the actual use case, you can always like find more training samples for your own domain and the specific problem. Okay, right. So here, as I said, we're going to actually to calculate the document embedding. So what is the embedding? So embedding is a vector of the numbers. Actually, like help us to understand how semantically similar or different the two texts are. So the closer the two embedding vectors are to each other, the more similar are their contents. So that is actually the cosine similarity, the concept, in the natural language processing. So this, the index stage can be executed offline and only need to run once to actually to pre-compute the index for the dataset so that each piece of the content can be retrieved later on. So since here we have some small dataset, we can always comfortably store and search the embedding locally. But if you have some larger dataset, you can consider using some vector search engines like this indicated here. Okay. So in following, we define some utility functions for like get embeddings, which is gives the get the any given text sentences embedding vector, and also create an embedding for each row in the data frame using the OpenAI embedding API here. Okay. So also is some load embeddings utility function, but here in this notebook, we are not going to use this function because we actually have our own the dataset, so we are always going to actually calculate our own document and embeddings using this command. Okay, you can see once I run the notebook, and we starting to calculation, and also just like to snip every 5 seconds per API calls to make sure I'm not exceeding the OpenAI API the rate limit. Okay, so after done that, see, so the document embedding is actually some dictionary type with the key value, where is the key is actually the our question index. The value is actually the document the embedding vector, which is like a list of the numbers here. Okay, that is clear. And then we can save our calculated document embedding vector for that use here, and then we can load it back the saved document embeddings to the pandas data frame for analysis. Okay, and then we can reconstruct the document embedding dictionaries from the pandas data frame. Okay, so that can always be like the done reversely, and to restore the any document embeddings we have been the calculated. Remember, we just need to calculate once, and we can use it as like a knowledge database for many times at the inference time. Okay, so in the second step, we are going to find the most similar document embeddings to the question embedding. Okay, so at the time of the inference, that is the question answering time. So in order to answer the user's query, we have to calculate the query embedding vector of the question and use it to find the most similar document, the sections, the document records, in our knowledge database. Okay, since this is a small example, we just store and search the embedding locally, and of course, if you have large dataset, using the vector search engine. Okay. So again, this is some utility functions. Vector similarity is actually returns the cosine similarity between the two embedding vectors. So this is all the document section by query similarity is actually defined the query embedding for the supplied query, and then compare it against all the like pre-calculated document embeddings in the knowledge database to find which one are most relevant and similar to this query. Okay, so then the result is that we are going to return a sorted list of temples. So in the descending order of this kind of thing. Okay. So each tuple will contain like the vector similarity between the query embedding and the each document embedding, and also the document index. Okay, so this is a list of tuples to be returned in this kind of the sorted list. So let's try it. So we can show like what is actually the top the most similar questions in the QnA database. So this is our the questions with whom can get in touch with to avail cashless benefit. Then our program managed to find the top two most similar the document the records in the knowledge database. Okay, here again, how to obtain the medical visa for myself. Our program managed to find the top three most similar the document records. How can I get a medical visa, what visa should I obtain to avail the treatment I have been asked to purchase, use medical aid, and so on. Okay, nice. So that is, we can see like the most relevant document sections for each question has been obtained, which is exactly what we want to know. Okay, right. So in the third step, as I said, we are going to add the most relevant document sections as the context to augment our query prompt. Okay, so once we calculate this most relevant place, the pieces of context, we construct a prompt by simply presenting them to the applied query. It actually is very helpful to using a query separator to help the model distinguishing between the separate pieces of the text. Okay, that's it. So you can see this is just like some code Here, this is actually the key functions, the construct, the prop. Okay, so um, here I define like some parameters, the top n. So that is actually the tunable parameter. So it allows me to actually to decide using the top n, the most similar record as a context. So for example, I can define it like top two. So that means I just using the top two most similar document record as a context to augment the query. So actually, originally, so the OpenAI's original notebook using the maximum section length. So maximum section length is actually the 500 tokens. That means they are keep like adding the document the record tokens to the to the context. Once actually the size is exceeding this maximum threshold, so actually they are actually to stop to adding the new content to the context. So here I just like disable it because through my experiment I found using the top n, the mechanism, here, okay, is actually the make more sense and make the program working more effectively to finding the relevant information included as a context. Okay, so this is just my little customize to the original notebook. Okay, for this basic the use case. Okay, so once we done that, just like to try using this utility function construct prompt. So this is our sample questions. My report are in regional language. What do I do with the Seven Hills Hospital? Yeah, okay. See, you can. We have found like top two document the most similar to this query, and then this is the header of the the for the air safety. Okay, and this is the context we added. Okay, this is the question. So finally, we actually managed to augment the original query with our additional information and context from our knowledge base using the the document similarity embedding technique. So that is quite nice. Okay, so yeah, once we done that, we can move to the final step, answer the user's question based on the context. Okay, we are close to there. So you just like specify some like the OpenAI's completion API parameters. Here, according to OpenAI's the recommendations, they are using the temperature of the 0 because it gives the most predictable and factual answer. Okay, nice. Okay, we just keep using the 0 here for our experiment. But of course, you can always have fun to actually to try different values if you want. Okay, so this is the utility functions answer the query with the context. Okay, so let's actually test it. This is our sample question. Okay, then you can see once you actually calling these utility functions, it actually to find the top two most similar document sections and add it into the context to augment the prop. And in this way, the GTP3 managed to actually to give the correct answers. We would recommend getting the summary of your records in the English language from your family doctor. In case that is not possible, we'll try and do the needful and so on. Okay, nice. Okay, so also have fun. I just compare it with the ChatGPT response here. Okay, this is the question, exactly same question, and the ChatGPT response here. Okay, so we can see like the compare with this kind of the prompt engineering based QnA bot, which answers this question correctly. The ChatGPT gives some either too general or too verbose or not so useful answer, to solve this particular issue. So you can see this is the ChatGPT's reply. Okay, just a bit like robust and too general. Okay, so nice. So by combining the embeddings and the completion API together with the the proper engineering technique, we have created a question answering model and the bot QnA bot, okay, which can answer questions using a large base of additional information and knowledge, and it also understand when it should reply don't know. Okay, So for this example, we have used the dataset of hospital FAQ, but actually that dataset could be replaced within any, the dataset, and for your specific domain. For example, books, articles, documentations, service manuals, or much more. So just like have fun to actually try, to explore and using your own data to actually to building your own bot like here. Okay. So there's also the more examples. For example, do I need to any person or agency to help me to contact the Seven Hills Hospital in India? No, you can directly get in touch with our coordinators. Nice, correct answers. If my family come with me, they can stay temporarily. Hospital offers guest rooms, family suite, dormitories, starting from the 15 USDs per day. Okay, nice. And I used to up my prescribed medicines which are available in my country. What do I do? And Seven Hills, the will courier the prescribed medicine to you, but on a chargeable base. Okay, nice. It's actually accurate and concise answers we are looking for. Okay, nice. And also for the air safety, it also like do the good job. For example, if the question is beyond the knowledge of the QnA board, and if it doesn't make any sense or it's not sure how to answer, it's just like the honestly say I don't know. Okay. So for example, what is the percentage of the India population who use Seven Hills Hospital? I don't know. Okay. Who won the tennis in the French Open 2022 man single? I don't know. Okay. Great. Okay. Nice. So finally, and also I don't need to be like the research on the reference quantity trade-off for the prop engineering. So it looks like some dark art or like designing how many reference documents I should include it as a prop context for GDP. For example, when I actually change the top end from like the 1 to a high number, sometimes GDP seems to be confused with like too much like the context information and cannot answer some questions correctly. So far, according to my experiment, it looks like the top n equal to 2 is like a good trade-off. But of course, I believe for the different use cases, you will find like the maybe some optimal values for yourself. Okay, once we done that, this is just data science work. So we want to actually to show our, the great, job to the other people. So we want to actually building some like the data app, to actually to to make it become some useful tools for other people to use. In this case, I would recommend the Streamlit. Okay, so this is a very handy tool. Actually, possibly the fastest way to building and share the data apps. So basically, you just need to actually to insert like the couple or like the API calls into your data science notebook, Jupyter notebook. That will convert the Jupyter notebook into some like the data apps in minutes and the hours, if not like the days, instead of like days or months, traditional like the building the data apps and web apps. Okay, so for example, that is super simple. I just copy paste my data science notebook in this Python script. Okay, so this and all the code I just like copied from the notebook, and then at the bottom you just start the Streamlit app, just like add some like Streamlit API calls, then it will instantly to convert the notebook into some like the app. So once I building this Jupyter node is Python script. Okay, so let's go to the command line. Just run the Streamlit run my the Python script here. Okay, see, it will actually to spin up in your web browser, and you see this is our GDP3 Q&A bot for Seven Hills Hospital query. So welcome to input any questions you want. Okay, for example, I got some more questions here prepared. How to travel to hospital from airport? Okay, Nice. Okay. Can our Q&A bot answer this question? Okay, answer found. Hey, your case manager will arrange for your pickup after receiving your travel document. International patient service team will send to you the name and contact details of staff, and the same person will escort you to the hospital. Nice. Okay. Yeah. So let's try another questions. Okay, let's try another question. Here. If my medical record got lost, can I get them back? If so, from where? Hey, your medical records are always preserved with the same health electronic medical record system. Will email the soft copies to you as and when you are required. Nice. Okay, just forgot to mention, in order to to make my Q&A chatbot do some like a more human-like the conversations. I just like to collect some like a greetings list and randomly pick up any greetings from this list and to add to as like the practice to like the answers to the customer's inquiry. In this way, give us like a more like the human-like the conversation style. It's just my final little tweak to this Q&A bot. So yeah, that's all. So this is how you see the answers look like. Okay, nice. So that is our quick demo. How can I build some like the Q&A bot using the GDP3 APIs as well as the prompt engineering technique for any specific use case and my own data. Okay. So okay, just don't forget to subscribe to the channel to keep updated on the latest AI machine learning model trends and download a copy of this slide deck plus many more free, the data science notebook and the resources available. Yeah, thank you and talk to you soon. Okay.